Hey guys, this is Ashiq Ummathoor. In this video, I'm going to explain what is OpenTelemetry and how to implement that in Kubernetes by using Grafana. Okay. So consider you have a two service A and service 2. You want to find the latency between service A and service B, then you have to use OpenTelemetry. If you want to improve your application performance and if you want to optimize, you must have to use traces. Let me show you how to implement this on your Kubernetes. Let's get started without wasting our time. See you there. I have already created my Kubernetes cluster. So now we have to understand what is the architecture of this OpenTelemetry, okay? And what are the components we have to create. So whenever you want to get a trace or whenever you want to take a OpenTelemetry data, so first you have to instrument your code. So what is mean by instrumentation? So basically code instrumentation, so we are integrating observability and monitoring with our code. So inside code, we will add some libraries. So this libraries will be responsible for sending the log data or traces data to our collector or agent. Okay, so here you can see that I have already instrumented my code. So this is my JS Node.js backend application. This is my Go application. So based on the language, we can go through the documentation and we can do the code instrumentation. This is basically has to do by the developers. But if you know, you can also do this. Okay, I have already instrumented my Python code, a sample code. Let me show you that. Okay, so here you can see that this is my Python code. This is I created from the ChatGPT only. You can see this is basically have a root/random. So when you hit this random, this will go to multiple span. So finally you will get a random number. Okay, so basically whenever you hit this URL, then /random, this will give a random number. So what I have done here, I created some libraries. You can see OpenTelemetry library. This library will be responsible for sending traces to my backend services or data. So this is we will explain later. This is basically send traces or logs from my application to my Grafana. So I'll tell you how this works. Okay, so you can see I specify the service name as feed service. You can put your service name over here. This is totally customizable. You can just add your service name, whatever the services you have. Now let's back to our diagram. So this is responsible for sending traces or logs or metrics to our backend services. So to collect these logs, we need an agent. So we have to create a collector, or this we will call it as a collector agent. So what is the purpose of this? This will collect the traces from these applications. Then this will validate and this will format. Okay, this is the purpose. So as soon as this is give the traces and logs, this will push to our backend service. So purpose of this backend service, this is responsible for store the data. So if you have a lot of data, this data will be stored in S3 bucket, or this will store in Azure Blob Storage or GCS storage. So you can take any storage as per your requirement. So here I'm using GCS storage. Finally, from this backend, we can collect the traces through Grafana. Grafana we are using for visualize our data through a graphical user interface. Here you can see this is my collector. So under collector, I have a values.yaml. So here you might be see maybe thousands of lines, but no need to overwhelm. This is actually I downloaded from OpenTelemetry documentation. We only need few data. Let me show you what all are important thing we have to see. Okay, so if you come to this 90th line, we have a config. Under config, you can see we have an exporter. So whenever we exporting the data, it should go to Tempo distributor. So who is exporter? So this is the collector. Whenever collector is exporting data, this should go to distributor. That's what I added my distributor URL here, 4318. Okay, so if I come down, you can see the receiver. Who is the receiver? I configured for Jagger OTLP HTTP. Basically this is the one our application is sending data. Then I have configured for Prometheus, Zipkin. These all are optional. If you don't want, you can remove this if you are not at all using. As of now, this is the default configuration. I haven't removed anything. I use the same as default. I have already applied this application on my Kubernetes. Let me show you that. If I open my Kubernetes, you can see trace collector, OpenTelemetry collector. This is already there. Let me open this and see the logs. See, you can see the logs here. So there are certain application is already sending traces. That's what you can see, data type trace, name debug, resource span, for span. You can see a lot of data here. Next, we have to implement Tempo service. So Tempo, this is a backend service. The purpose of Tempo, this is responsible for store the data. Okay, if you want to store the data, then you must have to use Tempo. Okay, so let me show you how to implement tempo. To implement tempo, first we have to go to this directory under tempo distributor, go to values.yaml. Let me show you some important settings. Okay, you can see bucket name. So as of now I have configured bucket for GCS. So as per your requirement you can configure this for S3 bucket, blob storage, Google storage, whichever you want. You can see URL, right? Just hit on this URL. Yeah, so now you can see that under storage we can configure S3, GCS, Azure storage, even local file system also support. Okay, so after that you can just apply this file. As soon as you apply this file, you will have a multiple ports. You can see that I have got multiple ports right now. Tempo, Courier frontend, Courier. I have a memcache. This is for caching. This is responsible for storing my data in my S3 bucket, and this is responsible for gateway access. But this is optional one. This is we can leave. This is same as distributor. Distributor is responsible for collecting the data from the collector. Compactor. This is compact the data. This is deduplicate the data from the GCS or S3 bucket. Okay, so let's see whether it's work or not. Okay, to test this we have to go to Grafana. Let me just log into Grafana first. After logged into your Grafana account, in left side you can see multiple options. So you can go to data source. You can see that connections. Under connection you can see add a new connection and data source. So you have to select add a new connection. So select Tempo data source because our backend service is called as Tempo. Click on this Tempo. Click on add a new data source. So now you have to provide the tempo. See, this is the name tempo. Under this you can pass your tempo service name. So now you can see this is my Courier frontend. This is responsible for query the data from Courier. Courier will take from our GCS storage or long-term storage. Okay, I have added my Courier frontend, then my namespace, then svc cluster.local, then at last my port number of my service. Let's go to my service and click on save and test, and you can see successfully connected to Tempo data source. To view the data you can click on explore view. You can click on the search. Here you can see multiple service name here. Now you can see I have added feed-service. This service we created for a demo purpose. If I come down you can see all the traces. So whenever I hit random this path, I'll get a trace, and if I click on this trace point, this will go to this trace ID, and this trace ID will give all the details. So whenever I hit this random, this will go to my number request, then child 1, child 2, then finally I will get my response. So total this is took 15 seconds. Now we can hand over this to developers and they will be able to collect the data, they will be able to optimize their application very well. Okay, that's it. If you need any support to implement this, please do reach me out, so I'll help you out. Thank you so much for watching my video. Bye.